Our target is write functions that represent transformations of functions. So we're going to rewrite. We've done the graphing stuff. Now we're going to write the equations that go with it. All right. So I can write functions that represent transformations of linear functions, and you will be able to write functions that represent transformations of absolute value functions. All right. So here's what family is this in? Linear, right? What's going to happen? We should know this by looking at it. What's that negative going to tell me? Right, reflects across the x. What's the plus 2 tell me? Going to go up 2. Very good. What's the domain? All real numbers range when it's linear. All real numbers, right? Because all x's and y's will work when it's linear. Okay? What about number 2? What family? Just a quick review. Quadratic, good. And what's going to happen here with our transformation? Down 2, which is a translation, right? Number 3, what family? Absolute value, good. And then what's that 2 out front going to tell us? Vertical stretch by a factor of 2. That means our y values will all be doubled, right? And what's the minus 2 tell us? Down 2. Good. And then for h, or h of x, number 4, that's a quadratic again, x is squared, right? And then the 2.2 is going to vertical stretch it by 2.2. And then the plus 2 inside is going to move it left 2. When it's inside parentheses or the absolute value, it's left or right, and it's the opposite way you think by looking at it. All right, good job. We already did that stuff. All right, so key ideas. Horizontal translations and vertical translations. Okay? So, I'm just going to write over top of this. This is in your book. You can look at all this, but this just gets kids all confused, looking at all that stuff. All right? So, I'm going to try to make it easy on you by giving you just an example and going through it. All right? So, oops, let me get that going. Well, I've got to do this first now. All right, so we're given a function. All right, this isn't a proof, so don't get worried. This is just what we're given for our function. So there's our function 3x minus 5. Okay? We want to translate it horizontally. That's left and right. This is a horizontal line, right? So that's left and right. Okay? So we want to translate it right 2. That's what we're going to do. Okay? So what that means we're going to do is write a different function. So we'll call it g of x. And all that means is to substitute in for x a translation that goes right. All right? So we're going to go 3, and then we're substituting in for x, moving it to the right, and then the minus 5 will stay. So what do I write to move it right? 2. I want to move it right 2. So I'm going to write minus 2, right? Or x minus. We need our variable, so x minus 2. Okay? And then we got to clean it up. We got to simplify it. So what do I got to do with that 3? What's that red stuff telling me to do? Distribute, right? So we're going to distribute. So we get 3x minus 6 and then the minus 5, which is 3x minus 11. So this new function g has translated or moved that function to the right 2 units. Okay? So we just substitute in that x minus 2. Remember, horizontally, left and right, we go the opposite of what we're thinking. So if I want to do the same thing, but I want to move it left 2, what's that going to look like? What am I going to put in my parentheses? X plus 2. So we just substitute in horizontally, we're going right, we're going to go x minus, whatever it tells us. If we're going left, we're going to go x plus when we substitute that in. All right, to clean it up, to simplify it, it's 3x plus 6 minus 5, which gives us the function g 3x plus 1. So that will move it left 2 from our original function. Okay? So that stuff behind that blue box, and it's in your book, just means to do that. Okay? So remember, right and left horizontally, that's what's inside the parentheses. If we're going vertical, we just add or subtract, right? Up or down, we do it on the outside. So we'll give you the same. Again, all this stuff sometimes is confusing to look, but basically all we're doing is adding a number outside the function. Okay? That's basically all that's saying. All right, so we're going to continue to use the same f function. F of x is 3x minus 5. So if I want to move it up 2, I'm just going to, my new function g is just add 2 on the end when it's up or down vertical. Okay? So horizontal, we're going to put x plus or minus, whatever they're telling us, the opposite of what you think in parentheses, and then distribute and simplify. When it's up or down, you're just adding it on the end of your original. Negative 5 plus 2 is negative 3. So there's the function that moves our original function up 2. Okay? And then if we're going to go down 2, what are we going to do at the end of our function? What am I going to put here? It's going down to minus 2. Okay? So those are the pretty easy ones. Horizontal is a little bit tougher to remember. But, you can if we were to graph those, you could see them move those certain ways. All right? We can use our technology to check if you want. Okay, so I go to my y equals to do a graph, right? So my original is 3x plus 3x minus 5, right? So that's all I hit. All right. So the first one, we were moving it right 2, weren't we? If I put 3x minus 11, let's see what it looks like when I graph them. There's the original. And there's the other one. Did it move to the right too? It did, didn't it? Okay, so you can check real quick if you want. What was the left two answer? +1? So I'll just go down here and hit +1, delete that other one, enter graph. We go left two, it went left two, see that? So we can always check if you want. Make sense? Any questions? Again, what family are we working with right now? Linear, right? These are linear. Okay? So, why don't you guys try these two examples real quick. Except I got to move that one up, other one up for you. So you can see them both. There's another one here. See if I can grab it. There we go. All right, so there's your f, your original function. We're going to translate it 3 units down. And then we're going to translate it 2 units left. So do those real quick, just for practice, please. I'll give you a few minutes. The A one's really quick, right? The B one might take you a little bit longer. Any questions back there? Make sure you simplify, clean it up. When it's up or down, where do I add or subtract? Inside for the x or at the end? It's at the end, right? Outside parentheses, right? So just -3. So our translation 3 units down will be 2x, what? Thanks. -2, right? 1 minus 3, right, William? This one, function h. Now, when we go left to right, remember we put it inside the parentheses. And then what was it? +1 on the end, right? So we're going 2 units left. Do I add 2 or subtract 2 inside the parentheses? Add 2, right? For left, you actually add 2 like you're going right. So distribute the 2 to clean it up. Oh, it's h of x. Sorry, I forgot my x. So 2x plus 4 plus 1, which gives us h of x equals 2x plus 5. Okay? Questions? All right. Those are pretty easy, aren't they? Vertical, horizontal. All right, let's talk about reflections. All right? So remember, if I draw a quick little graph, okay, and I have this red point here, and I reflect it about the x, which way am I going to go? Down, right? I'm going to go this way. How many spaces? The same amount, right? When I reflect it across the x. All right, so what changes? Like this, let's say this point was 2, 2. What's this point now? 2, -2, isn't it? Same amount, up and down, because it's a reflection. So what changes? The y value, right? So the y changes on a reflection in the x-axis. So the y basically gets to its opposite. Okay? So we're going to use the same function, our given, that we've been using. So 3x minus 5. And remember, that's the same as y equals 3x minus 5, right? F of x is function notation. Y equals is equation notation, right? So I'm making the y negative. So if the y equals this 3x minus 5, I got to make the whole thing negative. Okay? So what happens when I try to clean that up? What do I do with that negative? We call it what when we do this? Just distributing the negative. Okay? So this would be 3x, negative 3x, and then positive 5. When I clean it up, or I should make it g of x, sorry. Okay? So when you're reflecting across the x-axis, you're distributing negative through the whole thing. You put the negative out front of the whole thing. Okay? If we reflect about the y-axis, if I have this point, we'll just say it's 2, 2. Okay? And we go this way. What's that point going to be? What's its coordinates? Negative 2, 2, right? So what changed? The x changes, right? So x changes to negative x, right? All right, so if we have our given, f of x equals 3x minus 5, all right, my g of x, I just do the x part, not the whole thing. Well, what is 3 times negative x? If I clean it up, that's negative 3x, right? So when it's a reflection about the x-axis, we're taking the opposite of the whole thing, like distributing our negative. When we're going across the y-axis, we're just changing the x value to its opposite. Okay? Questions? All right. So far, so good? All right. So let's do this one together. We're doing across the x. Okay? And which family are we in here? Absolute value, right? So for our g of x, remember when we reflect about the x, it's the opposite of the whole thing, the y, right? So I'm going to put negative the whole thing. Absolute value of x plus 3 plus 1. All right, so when I distribute this negative, it just goes in front of the absolute value sign. You will not distribute to the inside of the absolute value sign. When it's parentheses, yes, but when it's absolute value signs, no. You just put it out front, there, and here. What's negative 1? It's like negative 1 times 1, negative 1, right? So we won't distribute inside, all right? So remember, thinking x-axis, we're changing our y's, right? That's when we change the whole thing. Put a negative out front, all right? If we do b, move this up a little bit. We're using the same f function. That didn't change. Now we're doing it y-axis, so we're going to change what? Just the x, right? Okay. So here we would write g of x equals the absolute value. We're changing the x, so it becomes negative x plus 3 plus 1. Okay? So we change the x. Questions? All right. So that was reflections. All right, so we did some translations, right and left, horizontal, up and down, vertical, and then we did some reflections. Okay? All right, let's talk about the stretches and shrinks, which we've done a little bit of that. We call them, instead of shrinks, compressions, right, Noah? All right? All right, so we're going to multiply the whole thing by a factor there for the stretch. Okay? Factor bigger than 1 for the shrink. It's between 0 and 1, like a fraction, right? We've been using fractions so far, right? All right, so again, this is similar to what we've already done, right? We've been graphing these, but now we are actually writing the equation. So again, we're going to do vertical stretch, and we're still using our given of 3x minus 5. We'll just keep using it, f of x. So if we want to do a vertical stretch by 3, I forgot my by, sorry. Okay, we're going to go g of x equals 3 times whatever my f of x was. So to clean it up, what do I do with that 3? Distribute it. So 3 times 3x and 3 times negative 5. That's the same function. Now we did a vertical stretch by 3. Okay? If we do the compression or shrink, by 1/2, we just put 1/2 out front of 3x minus 5. We'll call it G also. So distribute the 1/2. What's 3 times 1/2? Think of it like this. What's 1 times 3? 2 times 1. 1 times -5? 2 times 1. Okay? Or 1.5x minus 2.5 if you use decimals. So those are the vertical ones. You just put it out front. Okay? Those pretty easy. Basically what we've done already, right? Horizontal we haven't talked about much. Okay? So horizontal is harder. We think about. Again, trying to understand all that, that's hard to kind of understand. So here's what we're thinking. Big H for horizontal harder, all right? And think of it as 1 over whatever A is, which would be the reciprocal of what they're telling you, basically. Reciprocal of what they're telling you. So we're still given the same function we've been working with. F of x is 3x minus 5. And I want to do a horizontal stretch by 2. So you can think of it as 1 over 2, which is 1/2, right? Or what's the reciprocal of 2? 1/2, right? Flip it. So that's what we put inside with your x. So your 3's here, but you put it inside, so it's 1/2 x. For a horizontal stretch of 2, you're using the reciprocal of 2 times x, and then the minus 5. Okay? So that kind of stretches it this way. The vertical ones, remember, stretch it this way. Horizontal stretch will go this way. Right? Along the x-axis. All right, so what's 3 times 1/2 again? We just did it. Thanks again. Okay? So this is where we put it. Vertical, we put it out front of the whole thing, distribute it. Horizontal, we put it in place of the x, or times the x part. All right, so if we did a horizontal compression, by 1/2, that's like this, thinking about this, 1 over 1/2. Well, 1 over 1/2 is actually 2. All right? So we're going to use our same function 3 instead of, again, 1/2 x. Again, when we're stretching by 2, we use the reciprocal of 2. Compressing by 1/2, reciprocal of 1/2. So this becomes 2x. And then minus 5. What's 3 times 2x? 6x. So that's the equation of our original function f after it's been horizontally compressed. Again, if you have more than one translation, we've only been doing just one single one, right? Simplify the first one and then do the next one, right? Always simplify before you do another transformation. Okay? Always clean it up. Distribute. So if you get multiple translations, do one at a time and simplify. Or not translation, but transformation. These are all different types of transformations. Translations and stretches and reflections and compressions. Okay, so I know that's a lot I just threw at you. Any questions? You guys are awful quiet today. Doing such a good job of taking notes, right? Letting it soak in. Okay, so what's this? A function g whose graph is a horizontal shrink or compression by a factor of 1. Well, let's do this one. It's a little bit easier. First, I had a second one somewhere. There it is. A vertical stretch, the vertical one. Let's do that first. What do we do with that 2 when it's vertical? Out front of, and here's F again. You couldn't see it because I went down. Of the whole thing, right? So we're going to go, what does it say? Function h. So h is going to be 2, all right, times the whole thing. Okay, when it's vertical. So it'll just be 2 in front. You don't go inside. You just 2 in front, and then the 2 times the -5. Okay? You don't distribute into absolute values. That one makes sense? We got time to do that other one. I didn't know if we'd have time. All right, so this is horizontal, right? Remember, when it's horizontal, it's the reciprocal. What's reciprocal? 1/3. 3/1, right? So we just do it for the x, right? This is function g. So we're just going to put the 3 times the x, the reciprocal, minus 3 inside. So we just do it inside. See the difference? Vertical, it's times the whole function. Horizontal, it's just changing the x. So I multiplied the reciprocal of 1/3 times the x. Okay? So you're going to just practice those types of problems for homework. And this is your assignment. Thanks for your attention. Good job. Are we having issues still with our online book? Is anybody? You gotta, it seems like every time I try to get in it for myself, I have to do it twice. All right, so when you try to go to the ebook and it tries to get you to log in, just X out and then hit it again, the BIM, BIM, Big Ideas Math app tool on Canvas, and it should open it up for you. Okay? But if you're still having trouble, let me know. I'll try to help you through that. Callie, get that out, please.